Hello students, welcome back to our lecture series for subject mathematics 3. This is our first chapter, as you know, that interpolation, and we already completed some of the important topics in this chapter like Newton's forward interpolation formula, Newton's backward interpolation formula, Stirling interpolation formula, and in this lecture we will we will understand about what is Langrange interpolation formula. Okay, so first of all, uh, why we use Langrange interpolation formula? Because suppose you have unequal interval in x. Okay, suppose we know that this is our in table. There are two entries of x and entries of y. Okay, but suppose in x, suppose you have 5, 8, then 15, then 24, then 29. So here you can see that the difference between any two consecutive values of x, 8 minus 5, that is 3, 8 minus 5, that is 3, 15 minus 8, okay, 15 minus 8, so that is 7, 24 minus 15, that is 9, okay. Similarly 29 minus 24, 29 minus 24, that is 5. So here you can understand that this is unequal interval. Okay, you can say that unequal intervals, right? And for unequal interval, we cannot use Newton's forward backward interpolation formula, or we cannot use Stirling interpolation formula. Okay, so for that we have to use Langrange interpolation formula. In your syllabus for unequal interval, we have only two methods. First one is a Langrange interpolation formula, and then Newton's divided difference interpolation formula. Okay. So in today's session, I will explain about Langrange interpolation formula. Clear? For unequal interval. This is very important for unequal interval. And now suppose if you want to find the value of f of 6, okay, that means y of 6. Okay, that means at x is equal to 6, if you want to find the value of y, okay, we know that y is nothing but f of x. Okay, here suppose you want to find the y of 9, suppose you want to find y of 23, right, for unequal interval, and for that compulsory you have to use either Langrange interpolation formula or you have to use Newton's divided difference interpolation formula. Clear? Okay, I hope you all can understand. So this is a formula for Langrange interpolation formula. You have to remember just this formula, right? This is equation, right? X minus x1, f of x is nothing but this f of x is x minus x1. Now try to understand this formula, try to understand or this formula very carefully. See, just I want to explain the first step. In numerator there is no x0. See, x minus x1 starting with x minus x1, x minus x2 up to x minus xn. Clearly the values of x are x0, x1, x2 up to xn, okay, and the values of y that is y0, y1, y2 up to yn. Here as we discussed earlier. So in the first step x0 is missing. See, in numerator x0 is missing. Okay, x minus x1, we are starting with x1, x minus x1, x minus x2 up to x minus xn. And now in denominator, instead of x, just you have to take x0. So x0 minus x1, x0 minus x2 up to x0 minus xn, and multiply with y0. Okay, in first term you have to multiply with y0. Now the second term, in second term we don't have x1. See, again we know that entries of x is x0, x1, x2 up to xn, and entries of y, that is y0, y1, y2 up to yn. So in second term, here in numerator you can see that x1 is missing. Okay, we are starting with x0 but x1 is missing. X minus x0, x minus x2. Concentrate on this second term. X minus x0, x minus x2 up to x minus xn. Okay, clear? And instead of, in denominator, instead of x1, okay, instead of x, you have to put x1. So x1 minus x0, x1 minus x2 up to x1 minus xn. Here into y1. Okay. And now up to this, so last term is, you can say that in last term we have skipped xn. So x minus x0, x minus x1 up to x minus xn minus 1. So in numerator there is no xn, okay? And instead of x, now you have to put xn. So xn minus x0, xn minus x1 up to xn minus 1 into yn, okay? In first term you have to multiply with y0, in second term you have to multiply with y1, in third term you have to multiply with y2, okay? I hope you all can understand. Suppose you want to write third term here. So in third term, what is missing? X2, okay? X minus x0, x minus x1, x minus x2 is missing, x minus x3 up to x minus xn, and upon now instead of x you have to take x3. So x3 minus x0, okay, x3 minus x1, sorry, x2, okay, not x3, sorry. So x2 minus x0, x2 minus x1, okay, x2 minus x3 up to x2 minus xn, clear, and into y2. So this is your third term and so on, okay. So this is your Langrange interpolation formula to solve example for unequal interval. Most probably in examination they mention that use Langrange interpolation formula to solve this example or find the value using Langrange interpolation formula. So you have to compulsory apply this formula, okay. So let's try to solve some example. This is my first example, okay. Compute f of 2, okay. I want to find the value of f of 2 by using Langrange interpolation method, okay. From the following data, the data is already given, the value of x and the value of f of x, okay. Minus 1, the value of x is minus 1, 0, 1 and 3. Here you can see that unequal interval, because the difference between minus 1 and 0, that is 1. The difference between 0 and 1, that is also 1. But the difference between 1 and 3, that is 2. Okay, clear? So unequal interval, clear? The value of f of x is already given. Now I want to solve this example. So first I just write the value of x, okay. The value of x is minus 1, 0, 1, 3. The value of x is minus 1, 0, 1, 3, okay. And the value of f of x is 2, 1, 0, minus 1. F of x is 2, 1, 0, minus 1, okay. And we want to find f of 2, okay. Find f of 2, clear? So x is f of 2. Now first write formula. This is x0, this is your x0, x1, x2, x3. Up to x3 you have value. So f of x, okay. The formula using Langrange interpolation, that is f of x is equal to x minus x0, x minus x1, okay, sorry, starting with x1. So x minus x1, x minus x2, x minus x3 upon, now instead of x you have to take x0. So x0 minus x1, x0 minus x2, x0 minus x3 into y0, okay, and plus now x minus x0 as it is. Now x minus x1 is missing, so x minus x2, x minus x3 upon x1 minus x0, x1 minus x2, x1 minus x3 into y1, okay, and plus similarly x minus x0, x minus x1. In third term, x2 is missing in numerator, so x minus x3 upon instead of x, x2. So x2 minus x0, x2 minus x1, x2 minus x3 into y2. And similarly, x minus x0. In last term, x3 is missing, so x minus x0, x minus x1, x minus x2 upon x3 minus x0, okay, x3 minus x1, x3 minus x2 into y3. Now put all this value. What is your x? X is 2, okay, because we want to find the value of f of 2. So x is equal to 2, don't forget. So I just okay. So I hope you all can understand. Now put the value. Okay, I just erase this formula. Now put all this value instead of x. You have to put 2. Okay, so this equal to, I can write 2 minus 0. Okay, 2 minus 0, 2 minus 1, 2 minus 3. So 2 minus 0, 2 minus 1, 2 minus 3 upon instead of 2, now you have to take minus 1. Okay, so minus 1 minus 0, minus 1 minus 0, minus 1, minus 1, and minus 1 minus 3 into y0. Y0 is what? 2. So into 2 plus, similarly, put all this value. Okay, x minus x. So now I hope you can understand. So let's see how this all this example. See, this is my formula. Okay, x minus x1, x minus x2, right? X minus x1, x minus x2, x minus x3 upon x0 minus x1, x0 minus x2, x0 minus x3 into f of x0, and put all this value. See, 2 minus 0, 2 minus 1, 2 minus 3, same 2 minus 0, 2 minus 1, 2 minus 3 upon minus 1 minus 0, minus 1 minus 1 minus 1 minus 3 into 2. Now I hope you can understand what is your next term. Okay, so here see, x is equal to 2, right? So first in numerator we have 2 minus 0. Okay, 2 minus 0, 2 minus 1. Just I write here so you can easily understand. Here x is equal to 2. So 2 minus 0, 2 minus 1, 2 minus 3 upon minus 1 minus 0, minus 1 minus 1, minus 1 minus 3 into 2. Now what is your second term? Second term is 2 minus minus 1, 2 minus 1, 2 minus 3. Okay, right? And in denominator we have 0 minus minus 1, 0 minus 1, 0 minus 3 into y1. So y1 is what? 1. Here, see, here, okay. Similarly, 2 plus 1, 2 minus 0, 2 minus 3, okay. 2 minus numerator, 2 minus minus 1, okay. So that's why they write 2 plus 1. So 2 plus 1, 2 minus 2 minus 1, sorry, 2 plus 1, 2 minus 0, 2 minus 1. In last term, 2 minus 3 is missing, okay. And next is 3 minus minus 1, 3 minus 0, 3 minus 1 into minus 1, okay. The last term, see, here. So you can easily calculate this all values using your calculator. So first term is 0.5, then minus 1 plus 0, okay. And because see the numerator, okay, plus 0, because multiply with 0 here. So that's why the third term is 0, minus 0.25. So the final answer is minus 0.75. Clear? Let's try to understand one more example using Langrange formula. Find y is equal. Find y when x is equal to 10. Okay. The values of x is 5, 6, 9, and 11. X is equal to 10. Okay. X is equal to 10. So try to understand first term. What is your first term? See, 5 is missing. Okay. So 10 minus 6 in numerator. 5 is missing in numerator. Okay. So 10 minus 6, 10 minus 9, 10 minus 11. In denominator, 5 minus 6, 5 minus 9, 5 minus 11. Okay. Instead of 10, you have to put 5. So 5 minus 6, 5 minus 9, 5 minus 11. Clear? Second term into 12. Okay. Don't forget multiply with 12. Now second term, how you can apply? Now 6 is missing. Okay. In numerator. So 10 minus 5, 10 minus 9, 10 minus 11. Okay. And now in denominator, instead of 10, you have to put 6. So 6 minus 5, 6 minus 9, and 6 minus 11. Here. Now into 13. Here. And fourth term is 10 minus 5, 10 minus 6, 10 minus 11. Right? 9 is missing. 9 is missing. Here. So 10 minus 5, 10 minus 6, 10 minus 11. Now instead of 10, you have to put 9. So 9 minus 5, 9 minus 6, 9 minus 11 into 14. Clear? And 10 minus 5, 10 minus 6, 10 minus 9. The last term, 11 is missing in that case. Okay? 11 is missing. So 10 minus 5, 10 minus 6, 10 minus 9. In denominator, instead of 10, you have to put 11. Okay? So now 11 minus 5, 11 minus 6, 11 minus 9 and into 16. So calculate all this value. You can easily calculate this value, and that is 2 minus 4.3333 plus 11.6667 plus 5.3333. So the final answer is 14.6667. Okay. So let's take one more example using Lagrange interpolation formula. Okay, using Lagrange interpolation formula, find the interpolating polynomial. Okay, in this method, there are two examples ask that find interpolating polynomial. So when they ask about interpolating polynomial, so instead of x, okay, in formula, instead of x, you don't need to put any value. X is as it is, and when you calculate the term, all the terms, finally you will get one polynomial, and that is your interpolating polynomial. Okay. So this is your given table that x, the value of x is 0, 1, 2, 5, f of x, that is y is equal to f of x, that is 2, 3, 12, 147, and x is as it is. So here, this is my Langrange interpolating formula. Okay, x minus x1, x minus x2, x minus x3. You all know that in first term, x0 is missing. Okay, so x minus 1, x is as it is. So x minus 1, x minus 2, x minus 5. Upon 0 minus 1, 0 minus 2, 0 minus 5. Okay, so and multiply with 2. So this is your first term, x minus 1, x minus 2, x minus 5 upon 0 minus 1, 0 minus 2, 0 minus 5 into 2. Now x minus 0, in second term 1 is missing. Okay, so x minus 0, x minus 2, x minus 5 upon 1 minus 0, 1 minus 2, 1 minus 5. So this is your second term, and multiply with 3. Okay, multiply with 3. Clear? And the third term, x minus 0, this 2 is missing. So x minus 0, x minus 1 up into x minus 5 upon 2 minus 0, 2 minus 1, 2 minus 5. Okay, and into multiply with 12. Okay, plus the last term is x minus 0, x minus 1, x minus 2 upon 5 minus 0, 5 minus 1, 5 minus 2 into 147. Okay. Now we have to calculate this all the term. Okay, x is as it is. Okay, x is as it is. Now we have to calculate. So first we calculate that x minus 2 into x minus 5. So that you can easily calculate. We know that when we multiply this two brackets, so that is x square minus 2x minus 5x, so minus 7x and plus 10. Okay, so x square minus 7x plus 10, then multiply x minus 2 and x minus 5. So that is x square minus 2x minus 5x plus 10 again, once again. So x square minus 7x, okay, plus 10, right, into 3x. Okay, here 3 and this is x. So 3x, here 2 and this is x minus 1. So 2x minus 2, I can say 2 into x. Okay, in denominator here we have this 2 will be cancelled out. Here also you can see that 2 minus 0, that is 2, this is 1 and this is minus 3. So 2 into minus 3, minus 6. In denominator you have minus 6 here. Okay, and here 12. So definitely you will get minus 2 multiplied. Okay, so the third term you have 2x and here minus 1. Here similarly x minus 0, x minus 1, x minus 2, 1. Okay, so when we multiply this two term, x minus 1 and x minus 5, so that is x square minus x minus 5x, so that is minus 6x plus 6. Okay, so x square minus 6x plus 5, sorry, plus 5. Okay, and into 2x, right, because in denominator you have 2, 1 and minus 3, so minus 6 into 12. In numerator you have 12. So minus 1 as it is. Here you have 2. Okay, and x. Clear? So this is 2 and minus 1 as it is here. And 49x because of this is 5, this is 4 and this is 3. So in denominator you have 5 here, 4 and 5 minus 2, 3 and 1. In numerator you have 147. Okay. So clearly it will be cancelled out from 3. So that is 4 and 9. okay, and then 49 divided by 20. Clear? So that's why they write here 49 divided by 20. Okay, now you can easily calculate, take LCM as 20. Okay, because in denominator you have 5, 4, 20. So take LCM is 20. So this term you have to multiply with 4. This second term you have to multiply with 5. This third term you have to multiply with 20. Okay, and calculate. Finally, you will get this answer. This is our interpolating polynomial. Okay, x cube plus x square minus x plus 2. So in today's lecture, we discuss about most important method, Langrange interpolation formula. Remember this interpolating formula is generally we are using for unequal interval. Okay. So thank you.